Welcome everybody. My name is Koen Schelkens. I'm from Belnet and I am chair for this session where we're going to focus on virtual environments and respective emerging virtual communities. We'll take a closer look at new technologies being developed and implemented within this virtual context, and also have a look at where those technologies are actually used and what are the test results are. First of all, we have Dr. Luis Messina, who will shed us a light on how technology is implemented in Brazil's video conferencing technology, is implemented in Brazil's telehealth and telemedicine initiative. Secondly, we have Professor Wim Lamotte, who will demonstrate us a new architecture for large-scale virtual environments and how they can be implemented in specific contexts like education for sick children and tourism. And finally, we have Frederick Lesage, who will present us a very interesting case study about collaboration between artists and engineers using new possibilities of access grids and respective technologies. So before we start, again, I'd like to remind you to switch off your mobile phones, sound of your PC, and please don't forget to fill in your evaluation form. Those who completed the form at the end of the conference will receive a nice gift. So I would like to call Mr. Luis Messina to the floor, who coordinates the Brazilian Telemedicine University Network and manages EU projects in Brazil connecting cities in Europe and Latin America. And he will give us a presentation about Brazil's telehealth initiative. Thank you.
Okay, good afternoon. It is a great pleasure to be here. There are many projects going on in Brazil, and of course I will not be able to talk about all of them at the moment. There are about 30, maybe more, projects nationwide being supported by the federal ministries. But I will be mainly concentrated in these two projects here because they are really nationwide in their application. So these initiatives, the first initiative is being supported by the Science and Technology Ministry, and it's the Telemedicine University Network. And the second project is from the Health Ministry, and is our telehealth program applied to the primary health care. And we are very glad now that, in fact, we are experiencing new approaches in the integration of activities and a great synergy between our federal ministries, mainly the Education Ministry, the Health, and the Science and Technology Ministries. The Communication Ministry, we would like a much closer approach, but we still don't have it. But from the three first, we do have a great collaboration, and starting also with the defense. So, and we started in 2005, July 2005, to plan the Telemedicine University Network. In the first phase, there were 19 university hospitals and education hospitals. And then by the end of 2006, we came up to a new approval for 38 more university hospitals, bringing altogether to 57 university hospitals at the moment. And then the Health Ministry constituted then the Permanent Telehealth Commission, bringing more integration then to these activities, and launched the telehealth program from the ministry, health ministry. I point out these international workshops because they are really helping us to move to international collaboration between researchers in Brazil and in Latin America, in USA and Europe. The approaches towards Asia are starting, but we have not yet had actually workshops together. But with USA, we just signed an MOU for developing new technologies and tools to also to force a little more the health faculties and the university hospitals to collaborate and to bring more of their creation into our engineering facilities and new technologies. So, and the point is that we can do this now in Brazil and also in almost all countries in Latin America, because there is already an NRAN connecting basically in Brazil all the state capitals. All the 27 state capitals are already connected, although not all of them have already a very high band connection. Only these 3 rings, as you can see, the main cities, São Paulo, Rio, Belo Horizonte, and Brasilia, in the middle of the country, they are connected to 10 gigabit per second. And then the 2 other rings in the southeast and northeast. The other cities, they still have to prove their demands so that the NRAN can bring then higher connectivities to them. And I also emphasize the work being done from the European Commission and with, for example, the ALICE program, because this was one of the programs that really helped us moving into a telehealth, more integrated situation in Brazil and in Latin America. And the work from being done from Dante and Jean to build the Clara network in Latin America was of great importance and is still of great importance for the development and the integration of these countries in Latin America. And we are really using this opportunity. I bring this other project, which will bring and is already bringing for 5 state capitals in Brazil. There's still another one that it's not shown in the map. A high connectivity 1 gigabit per second ring. And it will bring this ring into all state capitals first. And there is already another project which already plans to bring for the biggest 10 cities in the country, but also will bring to some small cities, connecting basically the government, state government and city government, attendance centers, hospitals, small attendance clinics, and the schools in the state capitals. So this is, but still, not all the consortia is still. This should be already done. It's the same with our telemedicine project. Is the people it takes them too long to realize what they should do and how they should act in order to move things going faster. So in the first phase, then we brought connectivity, because this is the main part of the project. In fact, is to bring connectivity to the university hospitals and also to create, formalize telemedicine and telehealth unit in each of these university hospitals. So in the first phase, we came up to 14 states and 19 university hospitals. The half of them already had some projects going on in telehealth. Basically, second opinion with some cities in remote and underserved areas. So, what kind of infrastructure we should deliver to these university hospitals. Then, of course, the main point is to bring communication and enable this infrastructure communication, then guarantee the service quality for the video conferences, and we are already doing like video conference for 8 hours the whole day, and if it goes down, we bring it up very fast, so that it is really running now in a very precise and very organized way. Then stimulate collaborative research, medical assistance, and interinstitutional courses. It is running not in all of the 19 hospitals yet, but it is running already in about 12 of these 19 from these 19 institutions. Involve the main actors. We are involving already academy and government, but we do not achieve yet a collaboration with enterprises. I believe that the point now is coming that the enterprises are starting to agree and to understand that there is a big business here, and I believe that they will soon start collaborating much more. So provide indicators and evaluate these teleservices. Enable demonstration projects. This is everywhere. Each university hospital has to present its own project so that they receive then in equipment and scholarships, some scholarships, so that they can have also personal helping to move the work on. And so for the first 19, they have already all the equipment, and they have already launched, not yet all of them, but a couple of them, about 6, have already launched a formalized telemedicine unit in their hospitals, and organized the specialty groups, the special interest groups. So it is very welcome that our Federal Medical Council is supporting our activities. They are in charge of organizing the medical assistance in Brazil. For example, there are some differences. We must have a local physician close to the patient to give a second opinion in a remote from a specialist. So it is very different. We have to have a physician close to the patient. Okay. But and then we go in these 3 areas: the assistance, the education, and research. And these are the main 3 areas where we are already working. So medical video conferences between our national institutions, but also with international institutions. Then collaborative work and case studies with many institutions, then teleconsulting and image telediagnostic, then distant education and continuous education. We have, the universities in Brazil are very heterogeneous, we have many specialists in the big areas like São Paulo, Rio, Belo Horizonte, and Recife, but then in the country, we don't have that many specialists, although in some areas, like in Amazonas, we have specialists for tropical diseases and so. So we combine these activities and these specialties to have a better assistance for the whole country. That's the main aim. So some of the cities and some of the university hospitals already had experiences. We have a program in Brazil which is called the Health Family Program, which goes to the cities and to the houses of the poorest people and find out what the conditions are and then help these persons. And this program is running now much better and in a very wide way. We have about 27,000 teams working for the Federal Health Ministry. And from the Federal Health Ministry, the project is to give a better support, a continuous education for the family health program. And the state of Minas Gerais, for example, because of state fundings, they achieved a very high level of second opinion in electrocardiogram. For example, they are receiving already at the Federal University of Minas Gerais 300 to 400 electrocardiograms per day and giving second opinion on these electrocardiograms. And this comes then from around 200 municipalities. We have then a partnership, not only the Federal University of Minas Gerais, but other 3 universities in the state of Minas Gerais. And they also developed very well because one of the telehealth projects funded from the ALICE European Commission was based in Belo Horizonte, which is the state capital of Minas Gerais. Then the State University of São Paulo, which is enormous and has many projects, and one of the projects goes in the direction of computer graphics and simulating organs functionalities and dysfunctionalities of organs and how they can react to these. This is another project which has been funded also from the ALICE program, European Commission, for image telediagnosis, ultrasound, X-ray, and tomo. And then we see the necessity in the remote areas for a second opinion. But it's also difficult to find these physicians in the remote areas that are willing to cooperate. This project has also branches then in Colombia, and so that we could also collaborate not only with 2 states in Brazil, but also with other consortia in Colombia, and with Germany, Greece, and Spain. The other national program, telemedicine program in Latin America, which has already run some miles, is the telemedicine program from Mexico, and we are collaborating, articulating together so that we can bring more development for the whole Latin America countries. Also in Ecuador, we also have connections and articulations and project with Ecuador running. Okay, and now the project from the health ministry. They chose 9 states then to plan this work and to execute the work of with the university hospitals and giving second opinion to 100 municipalities in each state. The phase of this project, it is now like Minas Gerais had already achieved double as much, and the other cities, the other states are coming to 30 municipalities, 15 municipalities, and by the end of the year, we hope we will have at least 700 municipalities already working together with the second opinions. And as the other states did not receive this fund, the health ministry decided to bring then 2 points, 2 nodes in each of the other 17 states, so that we could also move in these states, although in not as much numbers of connections. And then we achieved this situation now, where we have, at the moment we have all the projects, but 6 did not give us yet their projects, but all the other 32 are revised and approved, and the equipment and the connection is being bought and is being planned. Probably for August we will start with the implementation in these new 32 university hospitals. So what each university hospital will receive is then a connection to a 1 gigabit per second metropolitan research and education ring, create a telehealth unit with video conference room, telediagnosis, teleconsult, and some of them also a tele-education center, participate in special interest groups, and demonstrate teleassistance, tele-education, and tele-research. At the moment, then, 12 university hospitals are already online, and we are doing already many video conferences among these university hospitals and also abroad. We hope that we'll have 7 more until June. And I don't believe anymore that we will have this 20 up to December. I believe more that we'll have about 12 until December. So, and then I believe that by the end of next year we'll have all 57. We have already approved a new phase for the project, and we chose then 12 institutions. These institutions are specialties institutions that belong to the health ministry. So at the moment we have already created these special interest groups, and they are running at the moment. The last one that we built was the children and adolescent health and medicine, connecting some of these interest groups. They connect 3, 4, 5, 6 institutions, and they make video conferences each 15 days or a month. Okay. To bring a little more and to so that they get more involved. There are some new budget coming from our financing institution, FINEP, which is the agency, the funding agency, supporting these projects. And we just achieved 14 new projects for the university hospitals, and there is already a budget planned for not only for research projects but also for education, for assistance, for standardization, and for managing. The university hospitals need still a lot. But in any case, there is a lot of new technology that this is on a slide from Parvati Dev, and we still don't know very much how to handle all this technology in a classroom. And so this is still a work very hard to be done, and especially with the teachers and in the schools and universities and medicine schools. This is one. We are trying to find out which universities in Brazil already have projects with other countries, and this is one of the first trials that we did to find out, and so in the way as to help them more and try to find more funding and for them to collaborate. This is a new project that we approved with the American Academy for Dermatology and the University of Miami. And in dermatology, there are monthly video conferences, and we are bringing more physicians then to participate. And as soon as they see, for example, what Shimizu just showed us, this they really get interested. Some of the surgeons, they just ask, when can I present something? When can I show my surgeries? But then we still have many problems with legislation, and how can these things then move on? The legislation on telehealth and telemedicine is still, at least for our country, not yet in the stage that everything can be done with no problem. So what we do is the patients participating in one second opinion or in some teleconsultation, they must sign a protocol accepting that they are being assisted by a local physician, but also receiving a specialist's opinion. And this is a new project that we just approved at the Inter-American Development Bank for starting the development of telehealth public policies in Latin America. This is very, very important because all these procedures must be standardized, and there is a big movement now in this direction for standardizing the procedures, the telehealth procedures all over the world, so that we can really be based on that and continue. So this participating in this project are Mexico, Ecuador, Colombia, which are the projects which are the countries that with whom we have a better articulation in this field. But then the Inter-American Development Bank asked us to bring also some other countries. And we are trying then to bring Uruguay, Argentina, and Chile, and El Salvador. So we're just about to sign the contract now in June. So that's what I wanted to present. Thank you so much.
Okay, thank you, Luis. Anybody has a question for Mr. Messina? Okay. I can give you the mic.
Wim Lamotte, Hasselt University. I was wondering if you have knowledge of any projects with neurology, because diagnostics are very specific in that area. And one has to coordinate between both video recordings and EEG and things like that.
Sorry. Oh, I'm sorry. I was looking at another picture. You said neurology. Yes. Not yet. There is not a formalized, because to all these specialties groups, they must be formalized. They to coordinate the telemedicine network, we built an advisory board which with participants from the biggest universities, from the biggest health centers in Brazil. And so to formalize a specialty group, some of the institutions, from a member institution, must formalize it and then propose it to the advisory board, and the advisory board then accepts it or not. So these are the specialty groups that are already approved and are already running. There are a couple more, around 4 or 5, I believe, that are in the process to be approved. But neurology is not yet asked. They did not request it yet. Okay.
And how is collaboration developing with Europe? Or is it growing or no?
Yes, well, it was one of the... I believe that one of the main start points was actually the ALICE program. Of course, from the European Commission. There were some already other projects running in Brazil, but they had no integration at all. Because of the demonstration of the European Commission ALICE program, we could show much more to the whole community what could be done. And based on that, the Science and Technology Ministry called us and requested a proposal for a national grid, as a national network. The collaboration then with Europe, we are of course very open, and we would like very much to collaborate much more with European countries, and so please, we would like very much to collaborate much more with the health institutions in Europe. And these specialty groups, I mean, they just have to be approved from the advisory board, and any other sort of collaboration. We are doing already live surgery, video conferencing, not yet at the high definition that Shimizu just showed with 30 megabit per second or so. We have done a couple of them with 4 megabit per second and 2 megabit per second. Also asking directly the physician that was operating, and this was a very interesting opportunity. But we are heading to enable also these high definition connection and possibilities. So.
Okay, thank you very much again, Luis Messina. Our next speaker is Wim Lamotte, who is full professor in networking and multimedia at the University of Hasselt, Belgium, and is also a member of the management committee of the Expertise Center for Digital Media in Belgium. Wim will demonstrate us his work on the an architecture for large-scale networked virtual environments, which will be also illustrated with 2 real-life use cases tests of this technology. Wim, please. Thank you.
Thank you, Mr. Chairman. I have to move the microphone a bit lower. Okay. There are a lot of names and acronyms on the slide here. I'm not going to explain them all, but one thing that I want to mention is that we are, as EDM, the Expertise Center for Digital Media, a founding member of the IBBT, which is a collaboration between the Flemish universities who are working on broadband technology, multimedia, and things like that. And in this context that we developed the projects that I'm going to demonstrate. So this is a short overview of what I'm going to say. First, I'll show the context in which we are working and doing this research and the goals of this research. I'll do 2 parts for the rest of the presentation. First, a more technical part on the architecture that we developed and are improving now. And then I'll conclude with 2 case studies that show the types of projects that we are doing with this architecture. So this is the context of the type of context of applications that we are working in, large-scale 3D virtual environments. These are the 2 most well-known current examples there, and Second Life. Second Life was already referred to by one of the speakers in the previous session, and it was also hyped the last few years. In all popular media, everyone knows Second Life, but apparently if I ask, for example, my students who's using Second Life, they all say, well, we just tried it, but we are not using it anymore. But apparently the mean age of Second Life users is above 30, so maybe that explains why my students aren't using it. So what are the goals of our research? Well, the main aim is to build up an architecture for large-scale virtual environments, because one of the problems that, for example, Second Life is having now is that they want to scale, but they can't scale yet with their current architecture. I'll come back to that later. We also aim at 3D environment. That's a bit of our previous background. We started out as a computer graphics laboratory. So that's where the 3D focus comes from. Large-scale aspect, of course, refers to the many simultaneous users that we want to support. If you look, for example, at many multi-user games, what the implementers of those games do is they make many different copies, separate copies of the virtual world, and everyone is just meeting people in their separate part, and they don't meet everyone who is virtually online. So we want to overcome that boundary also. Then communication is an important aspect. So we want to create social environments where people can communicate with audio, with video. And should also be multi-platform. So not only on PC, but also on mobile devices. I'm not going to give much detail on the initial architecture that we devised for it. Here are some of the highlights. It's a 3D environment that we divide into square regions. That's more or less the approach that Second Life is also using. So Second Life is divided in square regions, all of the same size, and each of those regions is supported by one server. What we associate with each of those regions is a multicast address, which is used for for exchanging all the data that needs to be exchanged between the different users. We did the same approach for video distribution. So in the left picture here on the slide, you see people using their webcam as input for their visualization within a 3D world. And also there we use multicasting for distributing the video streams in order to avoid to have to send multiple copies of the video stream to every other user. We use the concept of area of interest, which means that every user can define itself how narrowly or how broadly he wants to look inside the virtual world. That will also depend on technical issues, of course. If you have a low bandwidth network connection, it's no use to try to see the whole world, let's say. And on the right picture, you see the type of machinery that we use for simulating and for assessing the scalability of the architecture. So we don't try to grab hundreds or thousands of people to really use it. We just simulate users. I'll come back to that later also. After the first architecture, we extended this setup to mobile users also. That was also already mentioned in one of the previous talks in the early afternoon. People want to be online all of the time, not only when they are at home with a high-end PC and a good network, but also when they are mobile. We see it here even in the room. It's all with high-end PCs, but it's all mobile. What we did for that was make two solutions. One for really powerful handheld devices. We devised a local rendering engine, which you can see on the left in the three pictures, where we use it for a kind of 3D navigation aid within a city context. But for lower-end devices, it's not feasible to have them render a 3D environment locally. So for that context, we devised a remote rendering setup that you see in the right picture, where a virtual user is running on a server that renders for every mobile user that needs it its own view, and then sends that as a video stream to the mobile device. Here you see a screenshot of the different setups. So on the top, of course, a PC setup, which is viewing the local user and two remote users. And the two remote users are the two mobile devices on the bottom. The left one is using the local rendering. The right one is using the remote rendering. And you see that the video is a bit smaller there just because of bandwidth restrictions and even more the processing restrictions on the mobile device. While doing the projects that I'm going to present in the second part, we came across some deployability issues, things like the unavailability of multicasting on each and every network. Unless we use solutions like CastGate, a project from the Free University of Brussels, which provides a means to build up tunnels to the fully multicast-enabled network to have site-to-site multicasting. And a second issue that we wanted to tackle is the rigid world subdivision, which is, as I said before, also the main problem in Second Life. Like half a year ago or so, they put up a kind of an ad on their forum where they asked for a technical help a new technical director, let's say, to change to help change the whole server infrastructure. Because one of the main problems that they ran across to is when someone sets up a virtual event in Second Life and thousands of people go to that same place, of course that server can't manage the load anymore. So that's another problem that we want to tackle now. So this is the architecture that we are working on now. It's much more distributed. You see here that clients are connecting not directly to the core servers but to proxy servers. That's mainly to overcome local bandwidth problems, and also to overcome the fact that clients need to know to which server they have to connect. So the only connection they have to keep up is a connection with a proxy, and the proxy knows the rest of the underlying network. The logic of the 3D world is then allocated to what we call logic servers. There, all the state information of, for example, who is running where, who is putting which objects where, and things like that. But also autonomous avatars, bots that are running through that 3D world are controlled by those logic servers. I'm not going into detail on this communication flow here, but what we do is a multi-tiered setup to avoid too many communications to the client itself. Thank you. Switching to a very short demo video here, which was just uploaded this morning. So it's a very recent result that our people sent to me. What we are showing here is lots of clients which are simulated by a server that just generates those random walks throughout the virtual world. You see also that there are some clusters within the 3D world. And you see that some spaces get split up over time. That's just when the proxy notices too many clients are running in this area. So this is going to become a problem in the near future. So it gives a signal to the region management server, which then will split up that region, divide it over different servers, and then the average load is going down again. So this is what we are currently working on and currently testing as a new architecture. Okay, you can switch back to slides, please. Then I'm going to comment on two implementations that we made on the original architecture, which will, of course, be migrated to the new architecture. A first case study is a project that we call A4MC Cube, which stands for Architecture for Mobile Community Content Creation. A whole mouthful, but the goals are summed up here in the second bullet. So the idea was that we wanted to provide communities who are located in a certain area, in a certain city, to have communication means, but also to have a means to associate information with geographical locations. We also wanted to provide those communities with means to contribute to this virtual environment, and we also wanted to provide them synchronous and asynchronous communication means. In this setup, we used both the local and remote rendering setup on different types of devices. We ran this demonstration within the city of Hasselt, where there's a lot of Wi-Fi connection available. But I have to say that once we were actually running throughout the city center, there was quite some interference between different networks. Can I have the next movie, please? So this is a bit longer video demonstration. I'm keeping in mind the comment of the Polycom speaker this morning, who said that videos tell a lot of things that you can't say in a few words. I left out the the audio because it's in Dutch and it won't be of much use to most people. What we will see here is a bit of a mixture of things that we recorded within a lab situation and then also outdoor videos. We actually wanted to record people while they were doing things with a mounted camera, but due to the reflection of the screens, that wasn't working. So we had to afterwards show here in this lab setup what people saw in the real context. So in this demonstration here, you see some people walking around. These are actual users who never saw this application before and who were walking around through the city performing different tasks that we gave them just to assess the application. By the way, the different movement buttons that are used here are normally not used. So normally people are just located by their GPS position. And the 3D view is aligned with that position. So here you see one of the users who is associating some information with a certain shop. In this case, someone already put a message in a message board. Now this user is adding some of his own comments. So just does this by using the on-screen keyboard. So associated with each of the buildings, there's the possibility to have a forum, to have a picture or a set of pictures. In this second task, the users are taking a picture and then uploading that to their mobile device via Bluetooth. Once it arrives at the mobile device, it will be uploaded to the central server, where it will be a candidate picture to use as the 3D texture of that part of the city. So the original 3D world was just with all gray facades, let's say, and the users were adding their own pictures to the 3D world. That was one of the ways that they could add content. So that's what they did now. They added a new picture for this building. This wouldn't have been a good picture to use as a texture because it's not taken in the right direction. But okay. Then there are different types of views to be used. For example, here there's also a 2D view where the blue block is indicating where the other user is. So you can keep a list of buddies, let's say, that you can locate if they want, of course, to share their 3D location with others. You see on their face that they're really inexperienced users who are trying to find what they have to do. The next application they had to test was communication, so they can use audio conferencing to the other ones who are also walking within the city. It's also possible for users to add routes, walking routes throughout the city, and then these can be shared with other users also. You can see the walking route here in the 2D environment, but when we switch back to the 3D environment, you also see the red line running through the 3D environment, showing where people have to go. One of the next demonstrators that we wanted to use wanted to create is to have a virtual guide who is walking in front of you and taking you on a tour throughout the city center. And at the end, people filled in questionnaires, and those were used to update the software. Okay, can I have the slides back, please? The next case study is the ASCID project. ASCID is standing for this very long title here, again at my school, by fostering communication through interactive technologies for long-term sick children. So the idea is here to restore the social contact between long-term ill children who are staying first at the hospital, then at home, and their school environment. At the bottom you see some screenshots, but I'll show a demonstration video also further on. What was the motivation for this project? We see lately that the healthcare is moving more to the home environment. Many children, for example, who have to go to the hospital for treatment are kept there for the shortest possible period and then are sent back home for further treatment, further recovery, and things like that. Of course, this has an impact on the education that children can receive during that period. At several of the larger hospitals, there's also a hospital school, so there they can try to keep up with their education there, but at home it's a bit more difficult. We see that many children returning or starting to return from a long absence period have problems to reintegrate within the school environment. And not everything can be just solved by putting people near the children's beds, let's say. We started out with a user need and a task analysis by using previous research, which was also already available, but also by interviewing directly connected players like the teachers, the parents, the children themselves. And we also did some observations of people at home, at the hospital, to see how is the current way of working, how are children now still connected or not to the school. Out of that analysis and mainly out of those interviews, we discovered several needs, like the socialization is really missing. Children don't have really contact with their peers at school unless they come by at home, which is a pity, of course, for those children. Also, they do manage to keep up with the educational content of the regular classes, but extra information would be welcome to them. And also they would like to have a bit more contact with what is really going on at school and to be involved, for example, in group discussions. Coming out of those needs and observations, we came up with a setup which used audiovisual streams to have video conferencing possibilities between the children at home and at school, and try to give possibilities for active participation, like raising a finger in class. It's a bit difficult if you're at home, of course. This is the architecture that we used in this context. So we put a PC at home with the child, equipped with a printer and a scanner. Same equipment at school, but there also a digital camera, which can be used to either photograph the blackboard or the whiteboard, or to have pictures from the class, but also a webcam at both sides so that people can directly interact. What were the results of tests? We did tests with 4 children, I think, during the project period, but then afterwards we did, as indicated here, 25 installations at different children's homes and different schools. The main benefit to the children was socialization. The fact that they could, again, talk to their peers in school, see what they were doing, talk to the teacher, ask questions, hand in tests, things like that. gave them a much larger feeling of belonging to the classroom again. Those 25 installations were made after the end of the official end of the project, but it was extended with a few months just to roll out those extra installations, and that was supported by BetNet. It's not a typo, it's not Belnet, but BetNet, which is a not-for-profit organization which is really focusing on reintegration of long-term ill children. And they were already looking for a long time for a good solution for this kind of problem. Can I have the video here also? I have to say that this is also a video in lab setup, but it's exactly the same type of progress that the children at home are doing. So here you see the teacher logging into the system. The child is already online. He waves to the teacher. Then first, to make the environment nice to children, we made the playground a 3D virtual environment where they can play with each other, talk to each other with video and audio. As you can see here, above their virtual character, there's also always the webcam video, and the audio is also transferred. Once they want to do some more serious work, they enter the virtual school, where, for example, here a presentation can be shown, or they can enter the virtual classroom. Here you see the desk, the blackboard, a video screen, a library, and then that desktop here, the child can access things like the agenda, homework, things like that. So here you see the agenda, where for each of the days it can check what the children at school are doing, so we can see when he wants to try to be online. Things can be scanned into the agenda, things can be printed out if needed. The second book here in the desk contains the homework. So here if the teacher at school hands out homework to the children in the classroom, he also puts one copy on the scanner, and it's automatically sent to the child at home. In the library, there are different books that can contain whatever documents. For example, a photo album, where here the school festival or the school party is shown. Here you can see that the child can look at the whiteboard. When the teacher thinks that something really important is put on the whiteboard now, he zooms into the whiteboard, takes a picture. It's automatically added to the database, automatically available at the child's end also. And here you see the process of sending a task to the child. Just by pressing one button, it arrives at the other end. The child doesn't have to do anything himself. He can now fill it in. It's easier for children to do this like they are used to do, just on plain paper, and then send it back over the network, instead of doing it all electronically. And then it's sent back, and the teacher can, for example, correct the assignment here. Okay, you can stop the video here. Then I'll end with some conclusions. What we are working on is an architecture for deploying such 3D NVEs in different contexts, on different platforms. And they gained great user interest through the projects that we carried out. Even interest in popular press. Here is one example of what appeared in press. But the cartoonist here saw some extra features that we didn't build into the system yet, but maybe we can add them later on. Okay, that concludes my presentation.
Okay, thank you, Wim. questions?
Thanks. Leo Salavo, University of Latvia. Thanks for presenting the nice work. I have a question about one of the examples you said and showed that people are taking picture while walking through the city or town, and this becomes a potential content of the system, a keyword being potential. So somebody or something evaluates whether it fits or not. So two questions here. What is the mechanism of this evaluation? And the other question is, what happens when we have millions of users generating many kinds of content, not just pictures? Who's going to evaluate those, and how would that happen in the next version? Thanks.
It's a good question, because it's one of the topics that one of the other partners tackled within this project. You need some kind of moderation in this kind of environment. If just anyone can put just any picture in the system, it would be polluted with useless pictures, let's say. On the particular example of adding a picture of the facade of a building, we did that manually. So there was a moderator interface behind this system where every uploaded picture was automatically transferred to. And the moderator got a kind of an alert that new pictures were there, and they really had to pick them manually. Of course, you can start thinking about automatic ways of doing this, but I think in this particular context, it's still needed to have a human part within this whole chain of processing the data. Does that answer your question?
Thanks. The second part, what happens when you get millions of users doing that? Are you this is gonna create a lot of jobs, of course, for the moderators.
Yes.
Or is this gonna be enough?
Yes, it's true. And that's something that's not so easy to overcome. But also, if you look at current examples of people contributing to some common source, let's say Wikipedia, it turns out that not so many people are contributing to the same thing. It's mostly a smaller group contributing to some point of interest and other people to other points of interest.
So perhaps it might become socially moderated.
Yes.
Thanks.
Yeah, and that's what's also included within the system. I didn't draw your attention on it, but people can put stars next to those uploaded pictures. And they can also signal that some picture is inappropriate, for example. And then it can be automatically deleted, for example. Yeah, but social moderation is key here. Yeah.
Yeah, another last question.
Yeah, Camilo Zacconi from the Belgian government. Last year, I did participate for the government to the writing of a report investigating the use of new technologies, so new network technologies and IP technologies and those kind of stuff. 3D and collaboration tools were a part of the study. So my question is the following. Did you investigate, like you did, for instance, for the school example, the usage of your system for making e-administrations and e-government solutions and services?
Not directly e-administration or e-government, but more general things like e-conferencing or e-meetings. That is also one of the other projects that we did. Within a 3D environment, people meeting each other, exchanging minutes, things like that.
Because as an example, e-desk, as you just shown with the little boy interacting with his teacher, can be also a real collaboration between a citizen and a person from the administration without having the need to go to the city council or whatever.
The key is indeed to give some metaphor that people are used to. That's why we use the desk. That's what the pupil is used to when being in the school. So if you give some kind of metaphor that is not strange to the people who have to use it, it's always lowering the threshold to use those kind of services. Yes.
Would you be inclined to investigate a bit more if we, with government stuff, good?
Yep.
Perfect.
Okay. Thank you very much. Wim, thank you.
Thank you.
Now time for our last speaker, Frederick Lesage, who is a PhD student and researcher at the London School of Economics and Political Sciences, and is doing research on new media and organizational structures in creative industries. He will present us the results of his research and a more sociological view on how artists and engineers can work together in testing and using the new possibilities of communication technologies. Frederick?
Thank you very much. Hello, everyone. So, of course, I feel like being the last presenter, I will also be presenting something that's a bit odd, mostly because I'm kind of a neophyte. I won't be presenting much technical documentation or anything like that. I'm coming more from a social science perspective, looking at artists and organizational structures for using and appropriating information communication technologies. So how is this relevant to any of you? Yesterday, in the plenaries, Paul van Binst mentioned that in terms of these research networks, we have to start considering where these networks are going to go, whether they should be outward-looking or remain inward-looking. And so in part, this is useful for you in thinking about how to go and reach to, for other outside communities that aren't familiar with research networks and that sort of thing. And one of the ways that has already been used to reach out to these communities has been through technological experimentations, bringing in an outside community. Well, we've just seen a very good example of that, bringing in an outside community and trying to experiment with new technologies for serving their needs. This is one such example. I've been taking a case study through the, here we are. The presentation itself will be essentially a sort of a basic outline of my research, how I came across the access grid, how I came across the artists using this technology, followed by a sort of brief overview of some of the research that I've done on access grid in a sociological context. Then I'll sort of present one of the driving concepts that I'm using in this specific aspect of the research in analyzing experimentation, this sort of collaborative experimentation between engineers and artists. And finally, I'll present to you some examples of these types of collaborations and try to see how this concept can sort of tease out some new information, some useful information that some of you might find useful when working with artists or other new communities in the future. Now, my own personal case study for the PhD research in the Department for Media Communications at the London School of Economics has been a 24-month case study working with artists from the Marcel network. It consists essentially of participant observation of these artists, most of them located in France, England, and the United States, as well as Canada, and sort of following them around, looking at them working with between each other, working with technologies and with audiences. The idea is that as I spent some time with them, I started to see that they were developing their own kind of experimental practices, their own ways of dealing with scientists, with engineers, in order to be able to find what they needed when using new technologies. Essentially, the Marcel network has been around since at least 2001 in its current state. It was its first sort of big project was between Ryerson in Toronto and the Wimbledon School of Arts in London. It was one performance using the access grid, as a matter of fact. Now, this is going to be more of a sort of a historical presentation, focusing on the specific aspect of this 24-month case study. Now, while I was sort of introduced to these artists at the beginning, I came across one of the technologies that we're using extensively, which was called access grid. So this being a social science research and my not knowing anything about access grid, automatically had to sort of take a quick crash course in what that is. Now, I'm not sure to what extent all of you are familiar with what access grid is. Essentially, access grid is an ensemble of resources, including multimedia large format video and presentation environment. It's used initially, the idea was to enable people using grid technologies to communicate between each other and collaborate. It was developed by Futures Laboratory outside of Chicago with Argonne Lab. As early as 1984, there were iterations of the access grid. So it's been around for quite a while. Now, the idea behind the development of access grid in part was the sort of vision was that within the near future, this is of course mid-90s, within the future, bandwidth computing and imaging power will become effectively free, and high-quality audio and video capture will be increasingly inexpensive. I guess to a lesser, more or less extent, this is somewhat true. But it represents this idea that access grid was developed as a kind of kernel. It was built with the expectations that technologies would continually evolve, things would change, and eventually new things coming down the pike would replace it, possibly, or that it would evolve and become better. This is sort of the idea that access grid is an experimental technology. It was built by people in the academic community, in essence, for people in the academic community. It was built by researchers for researchers. Here is a kind of diagram of what the access grid is supposed to look like. In principle, here we see the access grid room as a sort of big green square with the 3 projectors, 3 screens, and the sort of conference room environment here. Now, I'm not sure, again, I don't want to start to expand too much on the access grid node, but the idea is essentially that it's a semi-immersive environment for video conferencing and collaboration between multiple nodes. What all of this I'd like to bring out mostly is the fact that it was conceived for a sort of abstract space, I would argue, and that when we start to look at actual iterations of access grid nodes, we see that it's a pretty standard type of room. It's a conference room. It's a very, very expensive conference room. We're in one right now, I imagine, in a way. You see tables, chairs, white walls. You see the projectors and the screen, and people sitting around discussing, having meetings. The idea is that it was built with sort of implicit social conventions, the conventions of conferences. We all knew when we came into this room that we were expecting chairs to be lined up in these lines with an alleyway in between so that we could all sit. We're all very familiar with these conventions of the conference room. We know that the person standing behind the podium is the one who's supposed to be talking. These sort of implicit conventions were the ones that helped to define the parameters of how access grid was conceived. So, in other words, if we go back to this kind of diagram, we see that really there are all sorts of implicit conventions that are also underlying the conception of this access grid, these access grid nodes. And if we talk about access grid as an experimental technology, there's also all sorts of implicit conventions that probably underlie its use. So when I talk about collaboration and experimentation, I mentioned earlier that research networks might want to reach out to new communities. But in the culture of experimentation, we all know that there's this idea of isolating variables, of being able to have your sort of control group, and make sure that when things change, you know what they're changing. Everything else kind of remains stable. This is an idea that's been brought forth in part by the likes of Simon Schaefer, who's done extensive work, sociological research on experimentation, and who calls this idea of the concept of transparency. If we talk about transparency, it's to enable us, when experimenting, to ignore the technological or social norms that underpin the experiment and allow us to focus on the point of the experiment. Where this comes into play when using the access grid as an example is that, as we've just said, in a way, conventions of conferencing are somewhat underpinning its use and its design. So prove it, right? So where this comes across is in the different case studies that I've done, or that the different cases that I've encountered over the course of the case study. I'm going to use a first example that's the 2001 SC Global took place at the 2001 SC Global Conference, known as Dancing Beyond Boundaries. This was a collaboration done between artists and engineers at the University of Florida, where they tried to, they essentially invited these dancers to come in and perform, which would then be broadcast over the access grid for everyone to see. Here we see on top the picture of the dancers actually participating in the event with the sort of half a moon-shaped screen on the back. And here we actually see a picture of the audience at the University of Manchester observing the event itself. You'll notice that, unlike what I've just been talking about in terms of the conference, the top picture is sort of a kind of very unconference-like room, whereas the bottom here is a very conference-like room, somewhat actually like you're all sitting right now. When you look at documentation that was produced around the development process of the event, one of the things that comes through, and I'll read the quote here from one of the engineers working on the project, was this idea that they found that AG and related technologies, access grid and related technologies, became almost transparent. This is, again, the transparency, and that the artists were able to articulate their needs to the engineers, and the engineers were able to reciprocate with descriptions of what the system could and could not do. So in other words, engineers inserted themselves between the artists and the technology and acted as kind of mediators, allowing the artists to say, well, this is what we'd like to do, is it possible? And then the engineers would say yes or no. But there's this idea that engineers are there to make the technology transparent for the artists, to sort of hide away all of the dirty, complicated things for the artist and allow them to focus on what they want to do. It's a sort of mutual process in that the artists benefit from not having to learn how the access grid works in order to use it, whereas the engineers are actually isolating, are looking at new uses for the access grid. They're actually being exposed to a new community of users who come in and might demand things that wouldn't have necessarily been obvious to the people using developing the technology. The second example, and I'll just move quickly along, 2002 Navigating Gravity, which is actually in part inspired by the Dancing Beyond Boundaries project. This one, in this case, was developed by Kelly Dipple, an artist from the UK, who was working with the University of Manchester as well as the University of Florida to do a similar kind of event, which was another dance event between multiple nodes, which would then be broadcast over the access grid. In this case, however, what the artists tried to do was work both in Manchester as well as at the University of Florida to sort of create both spaces, both nodes. And what came through in this is that some aspects of this transparency began to be kind of a little bit less transparent. I'm going to read a quote from the artist's diaries from when she was actually developing the work. The cameras in the video conference room at Manchester are attached to the wall and not freestanding. So I found the best place to avoid clutter is the very center of the room. Find a chair without arms if you can. It's easier. It's just a matter of zooming into you. And then I'll just move along. I would like to move the tables away from the center of the room as they are set up for traditional conference meeting rooms. This is the fact that here we start to see that it's actually not the technical aspects of the access grid that are intimidating or causing problems. It's actually the very plain issue of using someone else's conference room. There are tables in the way. The projectors are fixed to the ceiling, and obviously we can't move them because after I'm done, someone else wants to use the room. Of course, there's the also very plain idea that I can only book the video conference room for an hour. After that, someone else is coming to use it. So I only have access to the room in blocks of hours or this kind of thing. And then I have to coordinate the times that I can book in Manchester with the times that I can book at the University of Florida. They're very unglamorous issues, but key when you're experimenting with the access grid node, because you need to be able to have time on both ends to be able to use the technology. So what this brings out, and here I just want to sort of spin around a little bit, it's this idea that the people are attracted to access grid room because of its flexibility, because it allows you to do things that you can't do with, say, Skype or other video conferencing applications. The analogy that someone used over the course of my interviews was that access grid is kind of like a grill, whereas other video conferencing applications are kind of like toasters. The grill, the toaster allows you to do toast, but it doesn't really allow you to do anything else. Whereas access grid, like a grill, takes a little bit more time to do toasts, but it also allows you to do all sorts of other things, like cook meat or that sort of thing. This is the idea, again, coming back to transparency, of what Trevor Pinch calls the black box. Engineers, and I feel strange saying this to people who are much more familiar with technologies than I am, but there's this idea that if something is put in a black box, then you can't modify it, you can't change it. The technology becomes closed. And the attraction for experimentation is towards something that isn't in a black box. Is to taking it out of its black box and being able to fiddle with it, to toy around with it. But as we can see, in this case, the difference is that the artist comes in knowing full well that aspects of the technology won't be accessible to her. However, it's the other aspects that are also in a black box. It's the tables, it's the moving the node around, this sort of idea. Now, I'll move on to the third example, Streaming Tales, which was actually a work in 2005 by members of the Marcel network. So again, this coming in specifically to my case study and to aspects of the case study. The Streaming Tales was a project that was conceived by artists, French artists, in collaboration with an Italian artist, working from Birmingham in the UK and the University of Maine in the United States. The idea was to create an installation where they could invite a diasporic community, an African diasporic community, from both Birmingham and from Maine to come and meet and speak and discuss and exchange stories and this sort of idea. The sort of innovative idea behind the artwork was actually to take the social context of a meal. Initially, what they had planned to do was install a kind of symmetrical room with a dinner table and the meal, so that everyone on one end could sit around the table, and then a perfect sort of mirror image of that same room at the other end, so that it would look like everybody was sitting at the same dinner table, having a polite, casual conversation, and exchanging their stories of diasporic community and of their experiences moving away from Africa. What ensued was, after conceiving the project, they began working, testing out the access grid connections, testing out how they were going to install all of this. And again, we need to understand that these are done by artists who have little or no technical knowledge and some support from people within the academic community where they're doing it. In the case of in the case of Maine, it was at the University of Maine, whereas in the case of Birmingham, it was actually in a cultural center called the Public. What happened was that as they began to work on the technical aspects of setting up the node, they began to realize that, well, I'll just read the quote. For us, Access Grid's problem at some point is that the people who use it, mostly in universities, are in a kind of mindset of conferences. It remains about conferences. So who says conferences says rooms with tables with that light, although I guess in this case we've got a nice light set up. And we were trying to push to create a black box. Now here comes this term, the black box, again. However, in this case, it's actually inversed. For artists, especially those who have knowledge of theater, the black box is actually an extremely flexible thing. It's this idea of a theatrical space that can be completely modified in any which way, with a sort of blank grid at the top of on the ceiling, so that you can adjust the lighting any which way. You can move your stage. You can move where the audience sits any which direction. It's actually inversed. But as they worked towards getting this black box, and we could actually see it in the case of Kelly Dippel's work dancing in the previous work, we could actually see that she was trying to achieve this black box idea, dimming the lights, making it, taking out all of the chairs. It's this idea that the darker and the more sort of contained and blank it is, the more flexible the artists have as a space. And most of the artists that I've encountered while working in the case study actually reiterated this sort of goal of trying to achieve a black box, trying to gain access to a black box so that they could have full creative control over what they wanted to do. But again, as these artists started working on the black box, they got access to a theater space at the University of Maine, started putting things together, and they realized all of a sudden that their audience might actually be intimidated by coming into a black box environment, just as many of us who have never been into a theater would probably find it somewhat intimidating walking into a theater. So what happened was they were shifted away from the black box idea and began to use just a standard conference room, office room actually, in the university. with the expectation that this would make the audience more comfortable so that they could then interact with the people at Birmingham. Now, what I'm trying to get across in this sort of convoluted set of stories is that all of a sudden the artist's conception of black box and the engineer's conception of black box is kind of, they're both constraining, although they're both supposed to be very flexible. In fact, what comes through is that in the process of experimentation, both groups try to make certain parts of the technology transparent to the audience or to the user, when in fact what remains to be seen is how the user or the audience will actually react to what they need. So the benefit of these types of experimentations is actually starting to push the boundaries of what is and what isn't transparent in the process of experimentation. Finally, in terms of a conclusion, I'd just like to say that if we start to look, for example, at research networks and gaining access to new communities, we need to start thinking about the implicit conventions, the implicit standards that underlie the conceptualization of the spaces and the time that people use these technologies. In the end, we have to think about what we consider to be flexible and what we consider to be a black box, and how that, whether or not that, in fact, is the case for the communities that we're trying to invite and trying to bring into using our networks. Thank you.
Okay, thank you, Frederick. Any questions? None? Okay, but I have one for you. Are there now the case studies you made were from until 2005? Do you still have contact with those artists? Are people still experimenting with technology?
Yes, some artists are still experimenting with it. In terms of the actual case study, I've been the participant observation part of the study was between 2005 2007, so I haven't been keeping track of that. The thing is that a lot of the artists trying to use these types of technologies don't actually have access to the access grid nodes. One of the main focuses of the research has been following around the network as an organization, trying to negotiate access to the access grid nodes. And this is why the research itself is more of a sort of a social look at the technology as opposed to the physical constraints of its use.
Okay. Any questions? Okay. Frederick, I would like to thank you again. And this was the last session for tonight, so hope to see you all back tomorrow. Bye.